NENOMATICA, where mathematics meets YouTube excellence. For every a greater than 0 and a not equal to 1, f of log base of x equals 0 is equivalent to the system where log base of x equals t1 or t2, and so on up to tn, where t1 through tn are the roots of the equation f of t equals 0. The algorithm is powered by a simple substitution. Let t equal log base a of x. Then you first solve the simpler algebraic equation, f of t equals 0. Next, for every root ti, solve log base of x equals t, I to get x equals a to the power ti. Now, let's follow the algorithm on a concrete example. Solve the equation, open parenthesis, log base 2 of x, close parenthesis, squared minus 5 times log base 2 of x plus 6 equals 0. Step 1. Let t equal log base 2 of x. Then our equation becomes a simple quadratic in t. Step 2. Solve f of t equals 0. The quadratic factors as open parenthesis t minus 2 close parenthesis times open parenthesis t minus 3 close parenthesis equals 0. So the roots are t1 equals 2 and t2 equals 3. Step 3. Return to x by replacing t with log base 2 of x in each root. That gives the system log base 2 of x equals 2 or log base 2 of x equals 3. Step 4. Convert each to exponential form. From log base 2 of x equals 2, we get x equals 2 squared, which is 4. From log base 2 of x equals 3, we get x equals 2 cubed, which is 8. In this lesson, we will solve a logarithmic equation step by step, following a precise algebraic algorithm. Step 1. Introduce a substitution. Let t equal log x. Replace every log x by t. Step 2. Move all terms to one side, so the expression equals 0. Subtract 3 from both sides. Step 3. Combine the three terms using the common denominator open parenthesis t plus 1 close parenthesis times open parenthesis 5 minus 4t close parenthesis. Write the single fraction. Step 4. Expand and simplify the numerator. It becomes 2t squared minus 3t plus 1. Step 5. A fraction equals 0 only when its numerator is 0 and the denominator is not 0. So set the numerator equal to 0. Step 6. Solve the quadratic equation. Factor 2t squared minus 3t plus 1 as open parenthesis 2t minus 1 close parenthesis times open parenthesis t minus 1 close parenthesis equals 0. Therefore t equals 1 or t equals 1/2. Step 7. Substitute back t equals log x. If t equals 1, then log x equals 1, so x equals 10. If t equals 1/2, then log x equals 1/2, so x equals the square root of 10. Step 8. Neither value makes the original denominator 0, so both are valid. The solution set is the set containing 10 and the square root of 10. In this example, we will solve a logarithmic equation step by step, keeping the exact order shown in the reference solution. First, here is the problem. Then, we list the domain conditions for the base of a logarithm. Step 1. Let t equal log base x of 10 to simplify the expression. Replacing the repeated term by t converts the equation into a simple cubic in t. Next, factor the cubic exactly as shown. First, factor out t. Then factor the quadratic t squared minus t minus 6. Using the zero product property, list the three possible values of t. Before solving each case for x, recall the change of base identity. Log base x of 10 equals 1 over log base 10 of x. Case 1, t equals 0. That gives log base x of 10 equals 0. Using the identity, 1 over log base 10 of x equals 0. A non-zero numerator over any finite denominator cannot equal 0, so this case yields no solution. Case 2, t equals 3. Log base x of 10 equals 3. Therefore, 1 over log base 10 of x equals 3, so log base 10 of x equals 1/3. convert to exponential form to find x equals 10 to the 1/3, the cube root of 10. Case 3, t equals -2. Log base x of 10 equals -2. Thus, 1 over log base 10 of x equals -2. So log base 10 of x equals -1/2. Convert to exponential form to get x equals 10 to the -1/2, that is 1 over the square root of 10. Finally, we collect only the valid x values. The solution set d equals the cube root of 10 and 1 over the square root of 10. Example: solve the equation 25 to the power of log x equals 5 plus 4 times x to the power of log 5. We'll follow the exact 8 steps from the provided solution. Step 1. State the original equation exactly as given. Step 2. Apply the logarithmic exponent symmetry. A to the log base b of c equals c to the log base b of a. Here, that means x to the log 5 equals 5 to the log x. Now, write the updated equation. Step 3. Use the power rule to rewrite 25 to the log x as 5 to the 2 log x, then move all terms to one side to get 0. Also, announce the substitution, a equals 5 to the log x. Step 4. Substitute a equals 5 to the log x to obtain a quadratic in a. Step 5. Factor the quadratic to get a minus 5 times a plus 1 equals 0. Therefore, a equals -1 or a equals 5. Step 6. Test a equals -1. Since 5 to any real power is strictly positive, 5 to the log x cannot equal -1. So this option is impossible. Step 7. Use the valid solution a equals 5. 5 to any real power is strictly positive. 5 to the log x cannot equal -1. So this option is impossible. Step 7. Use the valid solution a equals 5. Then 5 to the log x equals 5, which implies log x equals 1. So, example, we will solve the logarithmic equation step by step, following the exact structure shown in the reference solution. The equation is open parenthesis log base square root of 2 of x close parenthesis squared plus 3 times log base 2 of x plus log base 1/2 of x equals 2. Step 1. Use the change of base formula to rewrite every logarithm with base square root of 2. That is, log base I of b equals log base square root of 2 of b divided by log base square root of 2 of a. Step 2. Evaluate the denominators. Log base square root of 2 of 2 equals 2, and log base square root of 2 of 1/2 equals -2. Step 3. Combine the linear logarithm terms. 3/2 minus 1/2 equals 1. Step 4. Multiply the entire equation by 2 to match the reference derivation. That produces 2 times log squared plus 2 times the linear log equals 4. Step 5. Move all terms to the left to form a quadratic in the logarithm. Step 6. Divide by 2 to simplify, then set t equal to log base square root of 2 of x. Step 7. Factor the quadratic. T plus 2 times t minus 1 equals 0. So t equals 1 or t equals -2. Step 8. Back substitute. If t equals 1, then log base square root of 2 of x equals 1, giving x equals square root of 2. If t equals -2, then log base square root of 2 of x equals -2, giving x equals 1/2. Therefore, the solution set is the set containing square root of 2 and 1/2. Example, our equation is open parenthesis log base 5 of x close parenthesis squared plus log base 5x of 5 over x equals 1. Step 1. Apply the change of base formula. Log base b of a equals log base 5 of a divided by log base 5 of b. Converting the second term to base 5 gives the first transformation line. Step 2. Expand using the quotient and product rules. Log of a over b equals log a minus log b, and log of a times b equals log a plus log b. Substituting gives the second transformation line. Step 3. Since log base 5 of 5 equals 1, simplify and set t equal to log base 5 of x. This yields the third line. Now introduce the substitution. Step 4. Substitute t for log base 5 of x. We obtain t squared plus 1 minus t over 1 plus t equals 1. Step 5. Combine terms over a common denominator and move everything to one side. This produces the fraction with numerator t cubed plus t squared minus 2t all over 1 plus t equals 0. Step 6. A fraction equals 0 only when its numerator is 0 and the denominator is not 0. So we solve t cubed plus t squared minus 2t equals 0. Step 7. Factor the polynomial. T times t plus 2 times t minus 1 equals 0. So t equals 0, t equals 1, or t equals negative 2. Step 8. Convert back to x using x equals 5 to the power t. That gives x equals 1, x equals 5, and x equals 1 over 25. Note that x must be positive and not equal to 1/5, which all three solutions satisfy. Therefore, the solution set is 1, 5, and 1 over 25. In this example, we will solve the logarithmic equation exactly following a clear step-by-step structure. The equation is open parenthesis log base 2 of x close parenthesis squared minus 9 times log base 8 of x equals 4. Step 1. Rewrite the base 8 logarithm using the same base as the first term. Because 8 equals 2 to the third power, log base 8 of x equals 1/3 times log base 2 of x. So the equation becomes open parenthesis log base 2 of x close parenthesis squared minus 9 divided by 3 times log base 2 of x equals 4. Step 2. Use a substitution to simplify the algebra. Let a equal log base 2 of x. Then the equation reads a squared minus 3a equals 4. Step 3. Move all terms to one side to form the standard quadratic. We get a squared minus 3a minus 4 equals 0. Step 4. Factor the quadratic and solve for a. This factors to open parenthesis a minus 4 close parenthesis times open parenthesis a plus 1 close parenthesis equals 0. Therefore, a equals negative 1 or a equals 4. Step 5. Back substitute to find x. If a equals negative 1, then log base 2 of x equals negative 1. So x equals 2 to the negative 1, which is 1/2. If a equals 4, then log base 2 of x equals 4. So x equals 2 to the 4th, which is 16. Finally, check the domain. Since x must be positive, both solutions are valid. The solution set is x equals 1/2 and x equals 16. X equals 16. Example. We will solve the logarithmic equation exactly following the shown algorithm and step order. The equation is log of log x plus log of log x cubed minus 2 equals 0. Step 1. Determine the domain. Because the argument of any logarithm must be positive, we need log x greater than 0. Therefore, x is greater than 1. Step 2. Combine the two logarithms using the product rule. We write log of open bracket log x times open bracket log x cubed minus 2 close bracket equals 0. Step 3. Convert from logarithmic form to exponential form with base 10. So the bracketed product equals 10 to the power 0. Step 4. Simplify 10 to the 0. It equals 1. Step 5. Distribute log x across the parentheses. We get log x times log x cubed minus 2 log x equals 1. Step 6. Use the power rule for logarithms. Log of x cubed becomes 3 log x. Step 7. Recognize a quadratic form in log x. That is 3 times open parenthesis log x close parenthesis squared minus 2 log x equals 1. And now we set log x equal y. Step 8. Substitute y for log x. We obtain 3y squared minus 2y equals 1. Step 9. Move all terms to the left to get standard quadratic form. 3y squared minus 2y minus 1 equals 0. Step 10. Factor and solve. The factorization is open parentheses 3y plus 1 close parentheses times open parentheses y minus 1 close parentheses equals 0. Hence y equals 1 or y equals negative 1 over 3. Step 11. Back substitute y equals 1. Then log x equals 1. So x equals 10 to the first, which is 10. Step 12. Back substitute y equals negative 1/3. Then log x equals negative 1/3. Hence x equals 10 to the negative 1/3, which is 1 over the cube root of 10. Step 13. Check against the domain requirement. We needed log x greater than 0 or x greater than 1. The value 1 over cube root of 10 is less than 1, so it is extraneous. Therefore, the solution set is D equals the set containing 10. Thank you for watching. Don't forget to like, subscribe, and hit the bell icon for more math lessons. NENOMATICA, where mathematics meets YouTube excellence.